In this section, we're going to use the distributive property to factor polynomials. Now let's just look for a minute at review real quickly with what the distributive property is. We've been doing that. If I multiply this out, remember we distribute the x to both terms, and I would get 2xy plus 2x squared y, plus xy. And I have used the distributive property. This is the factored form of this. In other words, if I started with this, I could end up with this by going backwards. So let's look at an example. If I had 15x plus 25x squared, and I want to factor this binomial. Well, the first thing I need is the greatest common factor. And if you can't immediately see what the greatest common factor is, we can find the greatest common factor, or the factors of each term. Okay, so if we look at 15x and I factor that, that's going to be 3 times 5 times x. And if I factor 25x squared, well, that is 5 times x times x. Now, the greatest common factor, remember, is what's common to both. So I'm going to circle what's common. I have a 5 and a 5, and an x and an x. So in this case, that's all that's common to both. The greatest common factor here between those two terms is 5x. Now, you might have been able to look at that and see that immediately, but if you couldn't, you factor each term and figure out what's common to both. So the greatest common factor is 5x. Now I'm going to use that greatest common factor and the distributive property in reverse to factor 15x plus 25x squared. And to do that, I can rewrite 15x as 5x times 3, and I can rewrite 25x squared as 5x, that was the greatest common factor, times 5x. Now notice 5x is common to both, so I'm going to factor that out, and we'll have 5x, and what's left is 3 plus 5x. Now notice if I use the distributive property, if I multiplied back through, I'd get 15x plus 25x squared, which is what I started with. This is the factored form. We're using the distributive property in reverse. So let's look at a few more of these before we move on to something a little bit more involved. Let's look at another one, 12xy plus 24 xy squared plus minus 30 x squared y to the fourth. Now you might immediately see that the greatest common factor is 6xy, but if you don't, let's see how we could find that. If I factor 12xy, well, that's the same as saying 4 times 3, or 3 times 4, which is 2 times 2, times x times y. So that's factored to prime factorization. 24 is 2 times 12, so we have 24xy squared. So I've already got 12 done, 3 times 2 times 2, and one more 2, or 8 times 3 is 24, times x times y times y. And then 30, or negative 30x squared y to the fourth, is negative 1 times 5 times 6, which is 2 times 3, times x times x times y times y times y times y. Now, if we're looking for what's common to all three of those terms, each one of them has a 3, and each one has a 2. Each one has an x, and each one has a y. So the greatest common factor is 2 times 3 times x times y. So the greatest common factor is 6xy. It's possible you could look right at that and see immediately that that's the greatest common factor, and that's great if you can do that, but if not, we can always easily find it. Now I want to use the distributive property and go back to my original trinomial, which was 12xy plus 24xy squared minus 30 x squared y to the 4th. Now I can rewrite each of those terms as factors of the greatest common factor and something else. So 6xy goes into 12xy. We had 2 left over. If we go back and look at how we had it factored out, we've got 6xy with just 2 left over. And you can look right there and see that that's the case. Plus 6xy. Okay, 6 goes into 24 8 times, and we'll have a y left over. If you're not sure, come back and look and see what's left here. No, 6 goes into 24 4 times. Where did I get 8? Excuse me, 4 times. 6 times 8 would be 48. All right, and we can see here the 4 and the y was left over. And then we have minus 6xy. Now 6 goes into 35 times, and x and y cubed. If you're not sure, come here. You can find your negative that goes in the front. But here's your 5, your x, and your y cubed. Now we factor out what's common. This is what's common. Our greatest common factor goes in the front, 6xy. And we'll have 2 plus 4y minus 5xy cubed. And there we use the distributive property to factor that trinomial. Okay? Let's do one more, just a second. Okay, let's look at this trinomial. If we go ahead and factor each term, we're going to have 7 times u times u times t times t. And then we'll have 3 times 7 times u times t times t. And then we'll have a negative 1 times u times t. And we can see that the only thing that's common to all three is a u and a t. So our greatest common factor is u, t. Now if I rewrite this and factor each term, factoring out the greatest common factor, we'd have ut times 7ut. And I can verify that because I have already factored that completely. Plus, notice this sign's always going to match. Then we have ut, and if I factor out a ut, I'm left with 3 times 7, or 21t. Minus ut times 1. It's very important that we keep that 1 there. Now if I factor out a ut, use the distributive property in reverse, I'm going to have ut and then everything else. I've got 7ut plus 21t minus 1. Don't forget the minus 1. That's part of the problem. All right, so we've looked at the greatest common factor, and we have factored a polynomial by factoring out using the distributive property and reverse the greatest common factor. We can use the distributive property to factor polynomials with 4 or more terms if we use grouping or factoring by grouping. So we're going to look at factoring by grouping. And there are some prerequisites to factoring by grouping. Still going to be using the distributive property, but when we factor by grouping, it has to have 4 or more terms. All right, you can't use factoring by grouping with 3. Terms must have common factors that can be grouped. Just because you've got 4 terms doesn't mean they have common factors that can be grouped, but to factor by grouping, the terms must have common factors that can be grouped together. And there must be 2 common factors that are identical or additive inverses of each other. There must be 2 factors that are the same or identical or the additive inverses of each other. Okay, so let's just look at, these are the requirements to do factoring by grouping. 4 or more terms. The terms have common factors that can be grouped. There are 2 factors that are identical or the additive inverse of each other. So we're going to look at some problems that we can do factoring by grouping. Okay, here I have a polynomial. It's got 4 parts. And notice these 2 and these 2 have a common factor. So if I group np plus 2n and 8p plus 16, I can find the common factor in the first grouping, which is n. And if I factor out an n, I'm left with p plus 2. Notice if I use the distributive property, I get np plus 2n. In the second grouping, I have an 8 that's common to both. If I factor out the 8p divided by 8 is p, and 16 divided by 8 is 2. Notice this is what's common to both. Same factor, so I can rewrite this as p plus 2. I'm factoring out what's common, and I'm left with n plus 8. And I have just factored that 4-part polynomial. Okay, let's look at another example. If I have Rn plus 5n minus r minus 5. Now in this case I have a plus and then 2 minuses, so I'm going to rewrite this one. I'm going to say Rn minus r plus 5n minus 5. Since I have 2 positive terms and 2 negative terms, and notice there's a common factor with both of those and a common factor with both of these, it makes it just a little bit easier. And we'll look in a minute at what we could do if we didn't want to regroup. But I think this is the easier way. In this grouping, r is common in the first 2 terms. So I'll factor out the r. Rn divided by r leaves me an n, and r divided by r leaves me a 1. Don't forget, it does not go away. R divided by r is 1. And then in the second grouping, I have a 5 that's common. And if I divide 5n by 5, I get n, and 5 divided by 5 is 1. Now notice this is common to both. N minus 1 times r plus 5. And I have just factored that 4-part polynomial. Okay, we're going to do one more of this kind. Just 1 second. Okay, here again I have a polynomial. Notice 2 positive terms and 2 negative terms. And if I regroup so that I have a positive and a negative, notice they both have common factors. And then 7x minus 7, my positive minus 7. The commutative property allows me to do that, move it around. The commutative property lets me do that moving. I can group these two, and I can group these two. Notice I always kept the sign that was in front of the term with it. So here in the first term, I have a 2y that's common to both. So we're going to factor out a 2y, and we're left with x minus 1. And then I have a 7 common to both. So if I factor out the 7, I'm left with x minus 1. And that is what I can factor out using the distributive property, x minus 1 times 2y plus 7. Notice we're using the distributive property multiple times here. Now we mentioned that when we do factoring by grouping, that the factors have to be identical or the additive inverses of each other. So let's look at what happens if we need the additive inverse. I have, let's say we have 2mk minus 12m plus 42 minus 7k. Okay, look, I've got a positive, a negative, a positive, a negative. So if we group, here I have a 2m common. And we're left with k minus 12m divided by 2m is going to just be 6. And in this grouping, I have a 7 common. 42 divided by 7 is 6. Now notice, that's almost what I want. These are additive inverses of each other. So what I can do to fix that is factor out a negative 1 in this second term. And I'm going to go back to the y. Okay, if I do that, I'm going to end up with k minus 6, because negative 1 times k is negative k, and negative 1 times negative 6 is positive 6, which is what I started with. So we have 2m times k minus 6 plus 7 times negative 1 times k minus 6. Let me go ahead and rewrite. This becomes a minus 7 times k minus 6. In other words, if we factor out a negative 1, the sign of both terms of that binomial change to the opposite. So now k minus 6 is what's common to both. And we're left with 2m minus 7. Probably need to do another one like this. All right, let's do c minus 2cd plus 8d minus 4. All right, looks like these two have something in common, and these two have something in common. First grouping, c is common. c divided by c is 1, minus 2cd divided by c is 2d. Here, 4 is common to both, so if I factor out a 4, I'm left with 2d minus 1. Notice, almost the same, but not quite. So if I factor out a negative 1, then that's going to change this to 1 minus 2d. If you're not sure, think about what happens if I multiply back through by a negative 1. We'd have a positive 1. Negative 1 plus 2d, which is what's in the grouping. So I can rewrite as c times 1 minus 2d minus 4, because we're multiplying negative 1 times 4, times 1 minus 2d. Now this is common to both, and we're left with c minus 4, and I have factored this out. Okay, maybe one more just to be sure that we are good with this. Let's look at 3p minus 2p squared minus 18p plus 27. All right. I think what I'll do to make this a little bit easier, I could rewrite this as 3p minus 2p squared plus 27 minus 18p, and that might avoid having to use the additive inverse. Let's see. Notice positive, negative, positive, negative. Okay, if I factor out a p in the first term, I'm left with 3 minus 2p. 9 is common in the second term, so 27 divided by 9 is 3. 18 divided by 9 is 2p, and this one's a little easier just by rewriting it. Didn't have to use the additive inverse. So sometimes that is a possibility. Yeah, let me use the eraser. So we get 3 minus 2p times p plus 9. All right. One more thing we want to look at today is solving equations by factoring, and this uses the zero product property. Sorry about that. My dogs just went nuts. They saw somebody outside. Okay, we're going to use the zero product property, which just simply is anything multiplied by 0 is 0. Okay, so let's say that I have (2d plus 6) times 3d minus 15, and that equals to 0. That means that either this term is 0 or this term is 0. So to solve, I'm going to set each factor equal to 0 and solve. So I've got 2d plus 6 is 0, or 3d minus 15 is 0. We have two solutions here. I'm going to subtract 6 from both sides, and 2d equals negative 6, divide by 2, and d is negative 3. Or add 15 to both sides, and we get 3d equals 15, divide by 3, and d is 5. So there are two solutions here. D could be negative 3, or d could be 5, because if d is negative 3, I'd have negative 6 plus 6, which is 0, and 0 times anything is 0. If d is 5, we'd have 15, plugging it in here, 15 minus 15 is 0, and 0 times anything is 15. So the zero product property allows me to solve these equations. All right, let's look at another way you might see some. You might have something that looks like this. C squared equals 3c. And I want to see what c could be. Because this is a second degree equation. It has two solutions. So the first thing I'm going to do is set this equation equal to 0 by subtracting 3c from both sides. We're not going to divide by c. That would only give us one solution. We're going to subtract 3c from both sides, and we'll have c squared minus 3c equals 0. We always have to have the equation equal to 0 in a situation like this. C's common to both terms, so I'm going to factor that out, and we'll have c minus 3. Now the zero product property says that either c equals to 0 or c minus 3 equals 0. And if I add 3 to both sides, we get 3. So c could be 3 or c could be 0. Two solutions here. Okay, remember, on one like this, don't divide by c. Subtract that 3c from both sides so that you have set the equation equal to 0. Let's look at 3n times n plus 2. Okay, remember, either 3n equals 0 or n plus 2 equals 0. So if we divide both sides by 3, 0 divided by anything is 0. If we subtract 2 from both sides, n is negative 2. So these are the two solutions here. One more let's do. If we had x squared equals negative 10x. Remember, I cannot divide by x. I've got to add 10x to both sides. And so we'll have x squared plus 10x equals 0. Set that equation equal to 0. X is common to both. So I'm going to factor out the x, and we have x plus 10 equals 0. So either x can be 0 or x plus 10 can be 0. Well, this one's solved. Subtract 10 from both sides, and x equals negative 10. So our two solutions are x equals 0 or x equals negative 10. Okay, your assignment is assignment number 12. And I want you to do on page 498, 16 to 44 even. And I've given you an example of each kind of problem I think that you're going to encounter in your homework.